right, jumping in. When we differentiate this, we are going to use implicit differentiation because it is not solved for y. So then I asked myself, what calculus rules could I use, or am I going to have to use for this problem? What product rule? So this guy is going to require product rule. You have the first d last, so x squared. Derivative of y is just 1, but every time I take a derivative of y, I need to write dy over dx, right? So that's first d last plus last d first, so times 2x. And then y squared, the derivative is 2y dy over dx. Derivative of -7 is 0. Okay.
And then you
It's free.
like you said, what time were we?
Are we good here? 1 d2 plus 2 d1, or last d first plus first d last. Then I'm going to subtract, this is 2xy, do you agree? That's just 2xy. I'm going to bring that term over here because it doesn't have a dy dx, right?
Yeah.
And I'm gonna group these together. So is it okay if I just straight up like take the dy dx out as a GCF first, and then just say it's x squared plus 2y? I save myself writing a step. And then to solve, I just divide, correct. So we divide by this, and you get dy over dx is all this stuff. Okay. You can't really cancel anything, so stays as is. Okay. Any questions? Okay, we are going to jump right into notes. Ready? Okay. So ladies and gentlemen, this is not a new concept, because look at my directions. I want you to find the slope of the tangent line to the graph of the given point. What does the slope of the tangent line tell you to find?
The derivative.
The derivative. This means, whoops, this means find the derivative, right? But then if I want you to find it at a given point, you are going to have to plug in and find a specific numeric value for the slope. Does that make sense? So if I just say in general, find the slope of the tangent line, you just find your derivative. But if I say find it at the given point, you need a numeric value. Okay. All right. So, do you recognize we are going to need to use product rule for this? If this is my equation. Okay. This is first, and this is second. Okay, ready? Okay, first d last. So we write 4 minus x times 2y dy over dx, because we took the derivative of y, is equal to 3x squared. Oh, I'm sorry. I just did first d last. So this is, sorry. First d last plus last d first. So plus y squared times the derivative of the first is -1. And we don't need a dy over dx because we derived x. So 3x squared. Okay, good. Then clean it up a little bit. So we have 2y times 4 minus x dy over dx. This is a negative y squared, right? Are you guys okay if I just add y squared to both sides? Is that good? Yes, no? Are you with me? I'm seeing some nods. Okay, so I'm going to say this is 3x squared plus y squared. Okay, so I just simplified y squared times -1 is -y squared, and I added it to the other side because it doesn't have a dy dx. Now, to solve for dy dx, I divide by this entire thing. I'm going to divide by 2y times 4 minus x on all sides. So I get dy over dx is going to be all of this, okay? But this is not our goal. This is step 1, find the derivative, okay? Step 2, we need to evaluate the derivative. Evaluate the derivative, dy over dx, at the given point, 2, 2. That was given, whoops, here. Okay, for this cissoid. All right, so they want you to evaluate it at that point that they gave. So I need to plug in, this is my x and this is my y, right? So I just plug it in to dy over dx. So I'm going to plug it in here. It's going to equal, okay, 3 times, they're both 2. So 2 squared plus 2 squared all over 2 times 2 times 4 minus 2. And then we just compute it, okay? It's thinking, I guess. Come on, computer, catch up. There we go. Okay. So simplifying, we get 3 times 4 is 12 plus 2 squared is 4 over 2 times 2 times, this is going to also be 2, right? So 2 cubed is 8. So that's going to be 16 over 8. So it's 2. So what does this number mean? What does that represent?
That's the derivative of that point.
Okay, specifically, did I answer my question? What did it ask me to find?
Slope of the tangent.
Okay, so is this the slope of the tangent line at 2, 2? Yes, this is the slope is the derivative. You know, we evaluated this at 2, 2. So there it is. The slope is the derivative at that point. So it is 2. So when I ask you to evaluate it at a point, right, you plug it in, you're going to get a numeric value. If I asked you just to find the slope of the tangent line generally, that's just giving me the derivative. See the difference? Okay. So you're going to see that theme kind of woven all throughout calculus, right? That's one big idea that you have to know moving forward. So, okay. The next piece is kicking it up a little notch. I want you to find the equation of the tangent line to the graph at the point root 2 minus 1 over root 2. Okay? I specifically chose weird values because you'll see that it's not too bad. Okay. If I asked you to find the equation, excuse me, the equation of a tangent line, do you guys know what 3 things we need to find the equation of a tangent line? We need 3 things. We need our slope, yeah, x and our y. We need m, x, and y, okay? We need 3 things. We need m, x, and y. We already have our x, y. So I need to find my first step is to find the slope of the tangent line at that point. But in order to find the slope of the tangent line, I need the derivative, right? Eventually, we're going to plug it into, oops, y minus y1 equals m times x minus x1, right? Your equation of a line, okay? All right. So step 1, find the derivative. So we're going to find dy over dx. We're going to use implicit differentiation since this is not solved for y. So, so we have x squared plus 4y squared equals 4. You do 2x. I don't need a dy over dx because I derived x, okay? And then this would be 8y dy over dx is equal to 0. Good. Then to solve for dy over dx, you just bring over the 2x, so you subtract it over, and you're going to divide by 8y. This reduces to negative, oops, sorry, I wrote x and I said y, divide by 8y. This reduces to negative x over 4y. Okay, so far so good. That is the derivative. The next step, find the slope at root 2 negative 1 over root 2. Okay, so m is equal to the derivative at that point. So I plug in my x and my y for these. So it's going to be negative times my x value is root 2 all over 4 times my y value is negative 1 over root 2. Any questions yet? Okay, so simplifying, let's do the algebra. This becomes negative root 2 over negative 4 over root 2. What happens to those negatives? Just become positive, right? So that's easy. Do you guys know how to deal with this weird fraction? What would you do? Yeah, I do reciprocal. Like you could multiply by root 2 over root 2. That's another way. But if it's just one fraction over another fraction, I just do reciprocal. It's just easier. So this is going to become the numerator times the reciprocal of the denominator, root 2 over 4. Pop that root 2 over 1. If it's not a fraction, just make it 1. So you get 2 over 4 is 1/2. Okay. Or,
Yeah, I believe.
yeah. Okay. Hold on, I want to make sure I did it right. Okay. I think I made a little stupid error in my notes. So, okay. So the next step is we plug it in to the equation, right? The equation of a line is, you need to know this, y minus y sub 1 equals m times x minus x sub 1. And I don't really care that you put it in slope intercept form with y equals mx plus b. If you plug it in here, I'm satisfied, right? Because I know you can simplify through. So this would be y minus, okay. I usually write, actually, before I plug it in, I usually write x equals root 2, y equals negative 1 over root 2, and m equals 1/2. Okay, so plug it in, plug it in. So we do y minus a negative 1 over root 2 equals 1/2 times x minus root 2. Okay. And then you get, I would just simplify the double negative, y plus 1 over root 2 equals 1/2 times this. And I'm satisfied with this. Okay. No need to do any more algebra. But I want to know that you know how to do the calculus. Okay. Good. All right. Next. Okay, this last one. Okay, I'm gonna show you this. I don't even know that I'll formally test you on this. But you will see this if you go to a college calculus class. So I feel like it's my duty to show you that this exists. However, if I remember correctly, we spent a little time on it, and my professor, even as difficult as she was kind of like, I remember in my notes, I even looked over my notes, my college notes from this, and it was like, don't worry about subbing in for the dy dx. And I was like, okay, so I'm just going to show you one example and we'll see how it is. Okay. But I don't super expect to give you a lot of practice or testing on it, just occasionally, so you see it. Okay, find d squared y over dx squared given that this equation. What am I asking you to find? Oops. Okay, which one?
With respect to y.
What's that? Okay, normally it's dy over dx, right? So it's squared. What does that mean?
Double derivative.
The double derivative, right? We need it. It's like f double prime, right? Okay. You find the second derivative, okay? So if we find the first derivative, implicitly, we say this is 2x plus 2y dy over dx. And I'm giving you like an easy one here. They can get really complicated really fast. So, and even though it's easy, quote unquote, it's weird. Okay. So, if you solve this for dy over dx, you subtract 2x, you divide by 2y. Oops, this is dy, sorry. dy over dx is cancel negative x over y. Okay. Now, you need to find the derivative of that derivative. Yes? So, step 2 is d squared y over d squared x is,
It says dx.
oh, dx squared, sorry, that's what I meant. Dx squared, d squared y over dx squared. Okay. The second derivative is, we have to use the quotient rule, right? So low d high, I do not need a dy dx, right? Minus high, which is negative x, d low, but am I taking the derivative of y? Right? Derivative of the low is going to be 1 dy over dx. Does that make sense? Yeah? Yes or no? Okay. All right. All over the square of what's below. Also, some of you are missing that on your quiz, so make sure with your quotient rule that you divide it by the square, so y squared. I did not take the derivative of y there, so I don't need to write a dy dx, but the dy dx is written in the numerator. Let me just clean this up and show you that we do have, this becomes negative y plus x dy over dx all over y squared. Now, normally, and this is equal to d squared y, your double derivative. When you look at answer keys in a book, like, because that's what you'll have in college, you'll have like maybe a solutions guide. It will tell you it equals some random thing, and you're like, they don't have dy dx in there. Yes.
X have to be y. Let the x be dx over dx.
Because here it was first d last plus, I'm sorry, low d high minus high d low. I took the derivative of y there. Yep. Yeah. I know that can be, you're like, did I do that right? Yeah. Okay. So they will take away and substitute in whatever dy over dx is for the dy dx and do all kinds of weird algebra to get a crazy answer. So we're going to plug in dy over dx. What did it say dy over dx is? Negative x over y. Does that make sense? So we're doing a substitution. So we're going to sub in dy over dx. So it looks like this. D squared y over dx squared is negative y plus x times negative x over y squared. Okay. This is going to equal, I'm going to go to the right. Negative y minus x over y all over y squared. Do you guys know the quickest way to simplify this complex fraction? Multiply by the complex denominator, which is what? Y, right? So all you need to multiply by is your complex denominator of y. So you multiply by y over y. And then you're going to distribute this. This is why I taught you this in trig. Okay. So you get negative y squared. And then here it cancels. So you get minus x. Oh, it should be x squared, shouldn't it? Minus x squared. Oh, yeah. Let me put the in the red. It should be squared. Oh, that is not very. Yeah, sorry about that. X squared. That was negative x times x is negative x squared. Okay, thank you. Okay, then, so it's negative y squared minus x squared. all over y cubed. Okay, and we can actually do one more thing. They'll do weird stuff. So like, if you look at your original equation, do you see, whoops, let me scroll up here. Do you see that we know x squared plus y squared equals 25? Okay. Now I have a semblance of that down here. I'm just going to write, we know that x squared plus y squared equals 25. So this numerator, couldn't I get an x squared plus y squared out of that? I could factor out a -1 and get x squared plus y squared all over y cubed, right? And this is 25. So I can replace x squared plus y squared with 25. So my final answer that you would see in the book is d squared y over dx squared is -25 over y cubed. Okay. So, and the thing is, like, you can kind of stop at a lot of places, but you won't be able to check your work very easily with these if you look at like a book solution. So, okay. So it's like a lot of algebra gymnastics. Yeah.